So when we are solving a question related to a turning effect, what is our first thing? We identify the pivot. That's the first point. Means identify the point of rotation, which is also known as a pivot. So when we identify the pivot, as in the question, they mention that this point is a pivot. So this is a point of rotation or pivot. We mark a pivot. The second thing, we consider the object is balanced or object is in equilibrium. So when object is in equilibrium, the forces, there will be forces, but these forces will cause the clockwise and anti-clockwise rotation will be equal. So first, weight is acting downward with direction, with reference to the pivot on the left-hand side. With reference to the pivot on the left-hand side, this will cause clockwise rotation. So this is the clockwise movement. And there's a force of 100 Newton with a hook with direction. This will try to cause a moment. It will cause an anti-clockwise moment. Because the object is in equilibrium, we always consider the anti-clockwise moment will always be equal to clockwise moment. So how to calculate a turning effect? It's a force multiplied by distance from pivot. So this is a pivot and 100 Newton is a force. So how much is distance between the force and the pivot? That is 50 plus 40, which is equals to 90. And the weight which is acting downward, which we don't know, multiplied by distance from the pivot, the clockwise, it is causing a clockwise rotation. So distance from a pivot is 50. So it will be 100 times 90 divided by 50. So when we simplify, 0 will cancel with 0. 9 multiplied by 100, like 9 multiplied by 100, 900. And then it is 900 divided by 5, which is equals to 180 Newton. So C will be the right answer.